Now let's take a few minutes to discuss how the HEUI injectors work. The HEUI injectors have four basic functions: to pressurize supply fuel from 65 psi to between 5,400 and 23,500 psi, to atomize the high-pressure fuel by pumping it through orifice holes in the injector tip, to deliver the correct quantity of atomized fuel into the combustion chamber, and to disperse the atomized fuel evenly throughout the combustion chamber. The HEUI injector has five major parts. They are the solenoid, the poppet valve, the intensifier piston and plunger, the barrel, and the nozzle assembly. The top one-third of the injector contains the solenoid, armature, and poppet. The solenoid is an electromagnet that creates a very strong magnetic field when energized. This magnetic field attracts the armature, which is connected to the poppet valve by an armature screw. As the armature moves toward the solenoid, it lifts the poppet valve off its lower seat. Energizing the solenoid and lifting the poppet valve off its seat is the beginning of the injection process. The poppet has two positions, open and closed. In the closed position, the poppet is held on its lower seat by a spring. The closed lower seat prevents high-pressure actuation oil from entering the injector. The upper seat is open and vents oil in the cavity above the intensifier piston to atmosphere through the upper portion of the injector. When the solenoid is energized, the poppet is lifted off its seat. This opens the lower seat, allowing high-pressure actuation oil to enter the injector and act on the top of the intensifier piston. The upper seat of the poppet valve closes, blocking the path to the sump and preventing actuation oil from leaking out of the injector. The center of the injector contains the intensifier piston, plunger and barrel, and plunger return spring. The intensifier piston is about 6 times larger in surface area than the plunger, providing a multiplication of force. This allows 3,500 psi of actuation oil to produce 23,500 psi of fuel injection pressure. When the poppet valve lifts off its lower seat, high-pressure actuation oil enters the injector and acts on the top of the intensifier piston. Pressure builds on top of the intensifier piston, pushing both the piston and plunger down. The downward movement of the plunger pressurizes the fuel in the plunger cavity, causing the nozzle to open and fuel delivery into the combustion chamber to begin. The barrel is the mating cylinder in which the plunger moves. The plunger and barrel together act as a pump, much like a medical syringe. Both the plunger and barrel are precision components with very small working clearances. These tight clearances are required to produce injection pressures above 20,000 psi. The barrel also contains the prime spill port. The prime spill port is a small precision hole that extends from the outside of the barrel through the side of the barrel and into the plunger. This port momentarily vents fuel injection pressure during the downward stroke of the plunger. The operation of the prime feature is fully explained in the pilot injection operation description. The bottom one-third of the injector is the nozzle assembly. It consists of the following components: the nozzle tip, the nozzle check, the nozzle case, and the inlet fill check ball. The nozzle assembly is similar to all other unit injectors. Fuel at injection pressure flows from the plunger cavity through a passage to the nozzle tip. Fuel flow out of the tip is stopped by the nozzle check, which covers the orifice holes in the end of the tip. The tip is held in the closed position by the force of the nozzle spring. This prevents fuel from leaking out of the tip and combustion gas from leaking into the injector when the cylinder fires. When injection pressure increases to approximately 4,500 psi, hydraulic force acting on the nozzle check overcomes the force of the nozzle spring. The pressure at which the check opens is called the valve opening pressure. Fuel flows out of the orifice holes in the end of the tip and into the combustion chamber. The check remains open and fuel continues to flow out of the tip until injection pressure drops below 4,000 psi. When pressure drops, the check closes and injection is stopped. The pressure at which the check closes is called valve closing pressure. There are 5 stages of injection with the HEUI: pre-injection, pilot injection, delay, main injection, and end of injection. Let's look now at each of the 5 injection cycles, starting with pre-injection. During pre-injection, the engine is running and the injector is in between firing cycles. All internal components have returned to their spring-loaded or non-actuated position. The solenoid is not energized, and the poppet valve is blocking high-pressure actuation oil from entering the injector. The plunger and intensifier piston are at the top of their bore, and the plunger cavity is full of fuel. Fuel pressure in the plunger cavity is the same as fuel supply pressure, approximately 65 psi. When the ECM determines that the injector should fire, it sends a current to the injector solenoid. The current causes the solenoid to produce a strong magnetic field, which creates a pull on the armature that's connected to the poppet valve by a screw. The magnetic pull of the solenoid overcomes the spring tension holding the poppet closed and raises the poppet off its seat. When the poppet valve opens, the upper poppet seat closes off the path to the sump, and the lower seat opens the poppet chamber to incoming high-pressure actuation oil. High-pressure oil flows around the poppet and into a passage to the top of the intensifier piston. High-pressure oil acting on the top of the intensifier piston forces the piston and plunger down. The downward movement of the plunger pressurizes the fuel in the plunger cavity and nozzle. When the pressure reaches the valve opening pressure, the nozzle check valve lifts off its seat and injection begins. The HI-300 HEUI fuel system has a unique feature called PRIME, which is an acronym for pre-injection metering. PRIME breaks the single large injection charge into 2 separate injections. It first produces a small pilot injection. A brief delay allows the pilot injection time to start burning. The main injection is then delivered into the flame front, established by the pilot injection. The main injection immediately ignites and burns smoothly and completely. This efficient combustion significantly reduces exhaust emissions and lowers overall engine noise by up to 50%, resulting in noticeably quieter engine operation. Now, let's take a closer look at how the PRIME feature works. The plunger's downward movement produces the initial pilot injection of fuel into the combustion chamber. When the plunger groove aligns with the spill port, high-pressure fuel under the plunger can flow upward through the holes in the bottom of the plunger, out the plunger groove and spill port, and back into the fuel supply passage. This loss of high-pressure fuel causes injection pressure to drop below valve closing pressure. The spring force of the nozzle spring overcomes the hydraulic force of the reduced injection pressure, and the nozzle check closes, stopping injection. This is the end of the pilot injection and the start of the short injection delay period. As long as the injector solenoid is energized, the poppet remains open and high-pressure oil continues to flow, pushing down the intensifier piston and plunger. Main injection occurs when the plunger groove passes the spill port and injection pressure once again begins to build, opening the nozzle check. Injection continues until the solenoid is de-energized, allowing the poppet spring to close the poppet and shut off the high-pressure oil. The end of the injection cycle begins when the ECM stops the current to the injector solenoid. The magnetic field of the solenoid collapses, and the poppet closes, shutting off high-pressure oil from entering the injector. As the lower seat of the poppet closes, the upper seat opens to the sump, causing the actuation oil pressure acting on the piston to drop. Fuel injection pressure under the plunger exerts an upward force on the plunger and intensifier piston. This upward force almost instantly becomes greater than the downward force on the intensifier piston, so the downward motion of the intensifier and plunger stops. When the downward travel of the plunger stops, fuel flow also stops. Injection pressure drops below valve closing pressure, and the nozzle check closes, ending injection. Exhaust oil on top of the intensifier piston can now flow to the sump through the open upper poppet seat, through the adapter, and out the adapter vent hole to the rocker arm area under the valve cover. When the nozzle check closes, injection stops and the fill cycle starts. The area above the intensifier piston cavity is open to atmospheric pressure through the upper seat of the poppet valve. The plunger return spring pushes upward on the plunger and intensifier piston, forcing oil around the upper seat of the poppet and out of the adapter vent hole. As the plunger rises, the 65 psi fuel supply pressure unseats the plunger fill check, allowing the plunger cavity to fill with fuel. The fill cycle ends when the intensifier piston is pushed to the top of its bore, the plunger cavity fills with fuel, and the inlet fill check ball returns to its seat. End of injection is now complete. This completes the description of how the HEUI mechanical components work.